Alrighty, you guys, so this is 10.3 similar figures. That's our standard. Your objective is to be able to show the connection between transformations and the orientation of similar figures. Again, with an 80% accuracy, given the practice from book or online sources. Similar is a little different from congruence. Remember, for congruence, for two figures to be congruent, they have to have the same shape and size. This one only has to have the same shape. So similar figures are figures that are similar, meaning they can be obtained from different transformations, reflections, rotations, dilations, translations, and they only have to preserve the same shape. They don't have to have the same size. Okay, so in this case, similar figures do have the same shape. They do have to have the same angle measurements, because remember, even when you shrink it and when you enlarge it, the angle should be the same. The angle measurement should be the same. Not the sides lengths, but the angles. But they do not preserve the same size. So that was going to be a no. Okay, so let's go ahead and look at this one and figure out if those are similar. Okay. So first thing we're going to go is we're going to see if from here to here is similar. Meaning, if you perform translations, reflections, rotations, dilations, reflections, okay, and see if I'm able to go from here to here with just those four different transformations, okay? So I know for sure that that's a reduction because I went from big to small. So I know that's a reduction, and I need to find the scale factor. So the easiest way for me to do that, instead of looking at my order pairs, is just looking at the one of the side lengths, and I can do that for each one of them. And so I'll do it just because I know these ones are actually similar. I'll just do it with the side lengths, but we can do that. Actually, I can do with the side length and show you some math for the next module. So this from A to B is 2 units, okay? From A to C is 1, 2, 3, 4, 5, 6 units. And then from B to C, I'm gonna show you Pythagorean theorem really quick. So we know that for right triangles, a squared plus b squared equals c squared. So this is my A, this is my B. C is always the longest side, the hypotenuse is opposite to the right angle. So then in this case, I have 2 squared plus 6 squared. Is that true? That is c squared. So then I have 2 times 2 is 4, and 6 times 6 is 36, and that will give me a square root of 40. Okay, and I'm gonna hit that in the calculator. And I'm gonna do it on this one, see if I get the same thing. So, square root of 40, I get approximately 6.325. I'm gonna stop there because it keeps on going. It's an irrational number, so it's not perfect square. And then let's compare. So this is gonna be, so this is my CB, about 6.325 units, okay? And so let's look at this one right here. I have A prime, B prime. I have A prime, C prime, and then I have C prime, B prime. Okay, so A, B is 1, 2, 3, 4, 3. 1, 2, 3 units. Oops, I did this wrong. That's AC, so that's 3 units. And then this is 1 unit. Should be leaving here. And then this one, I'm gonna square those two. So I have 1 square plus 3 square, and that's gonna give me my C square. So I have 1 plus 9 equals C squared. So 10 equals C squared. To get rid of the square, I have the square root right here. So and that's C approximate square root of 10. And so square root of 10 is about 3.162. Okay, and remember, to find my scale factor, I'm gonna do prime over original. So let's do that. So prime over original, so I have, for this one, so I have 1 over 2. Prime original, 3/6, that's also 1/2, so check, check. And then this one right here, that one's a little tricky, right? So prime is that, 3.162 divided by 6.325. That looks like it's twice as that, so that's about 1/2. It's actually 1/2. So then I know that I went, you know, my scale factor is 1/2. So my scale factor is 1/2. So half, or 0.5, so 5/10. Okay. So how do I write that as an algebraic formula? Rule, I'm gonna do 1/2 x, comma 1/2 y. You can also write it as this. So that's a matter of preference if you prefer fractions over decimals. Okay. So let's go ahead and erase that. Maybe you're a little confused with the Pythagorean theorem with the triangle, but that's the next module actually. Okay, so then I know that the sides look the same, but it's not just, you know, shrinking it over the same center of dilation. So there has to be some kind of translation where I moved it. So then the question is, if I was supposed to have, because this is 4,2, so if I were to reduce it by half, that will give me 2,1. So that will be right here, that will be my 8 prime, okay? But I went from here all the way up here. So then I have to check how much I moved to the left and up. So when I went 1, 2, 3, 4, 5, 6, I went 6 to the left, and I went 1, 2, 3 up. Okay, and so I checked that with each one of them because I should have the little triangle right here, but it went up here. So then my rule is x comma y, and then I move. This has to do with my x, so I'm going to the left, so I'm going to subtract, and then comma y plus 3 because I'm going up. Okay, so the question is, did I use perform translation? Yes. Reflection? No. Rotation? No. And dilation? Yes. So as long as I did any of those four and the shape is maintained and the angle of measurements are the same, even though the size shrunk, it is a similar figure. So these two are similar figures. Okay. I'm gonna have you do one, so practice, and then you're gonna tell me if it's similar or not and why. Okay, tell me why, if they're similar or not, and why not. If they are, what kind of transformations did I do? Okay, and then if they are not, why is it not? Why are they not similar? Okay, God bless you. Bye.